Welcome everyone. So today we are going to learn the topic of physics of class 6 standard 8 9, which is work, energy and power. Now here you are seeing two people. You must have known these people by their name. First one is James Joule for his valuable contribution towards the work. So the unit of work is Joule, which is named after him. Similarly, you must have heard of steam engine. So the person behind the invention of steam engine was James Watt. So that's why the unit of power is watt. So this is the agenda of today's presentation. We are mainly focusing on learning work and energy in this presentation. So first of all, let's see the real life examples of work. A person sitting on a cart and a horse is pulling the cart. You are seeing the picture. So now what is happening here? A horse is pulling a cart and person is sitting on a cart. So what kind of force acting over here? It's called pulling force. And with the help of pulling force, we call the person can move in the direction of horse horse moves. So this is called work done, positive work done. Similarly, a person is climbing on the stairs. Here he is climbing up, so he is giving his masculine energy against the gravitational force, and due to that work is going done. He is climbing up, so that can be example of work done. Similarly, here what you are seeing, car is passing down the road. So here engine is doing the work, and what kind of work engine is doing? Engine is producing mechanical power, mechanical work, and due to that engine runs and car is moving across the road. Similarly, here the ball, when we throw ball upwards, so the gravitational force comes into account, and it attracts the ball coming towards the earth. So due to that, a ball never go upwards throughout the time. It comes back and falls to earth. So it is also one example of work done. Similarly, scientifically, when we say scientific definition of work, then work is said to be scientifically done when force is applied on a body and it produces motion. Now here we look on the formula of work done, which is force into displacement. W is equals to whatever amount of force we are applying on the object and the displacement that object has covered. Similarly, the work is a scalar quantity. Here in the last slide, you have seen the formula of work is F into S. So it's a scalar quantity. So W is equals to F dot S. And you must have learned in maths about the dot product. So if we simplify the dot product, it will give us Fs cos theta. Now, work can be positive, zero, or negative. We will see further slides what about the positive, zero, or negative work. Similarly, the unit of work is joule. W is equals to F into S. The unit of force is Newton. The unit of displacement is meter. So when we multiply together, so the unit of work is Newton meter, or we can say it as joule also. So that's why we can found out that 1 joule is equals to 1 Newton meter. That is SI unit of work. Similarly, CGS unit of work is erg, and this is the relation between joule and erg. Now let's see about positive, zero, and negative work done. If we apply force on the object and it moves in the direction of applied force, then it's called as positive work. Similarly, if it moves in the opposite direction of motion, then it's called as negative work. And if it produces zero motion, then we can call it as work done is zero. So after simplifying the formula, W is equals to Fs cos theta. If the motion is in the direction of force applied, so the angle between both of them is zero. So that's why the maximum amount of work done we can achieve. Similarly, here the maximum amount of negative work which we can achieve, and here the work done is zero because of no motion happening in here. Similarly, what is energy? So energy is the ability to do work. What is energy in simplified terms? So basically, amount of energy possessed by a body to do the certain amount of work. That's called an energy. When we have some work to do, we require some energy, and that's the energy we call in scientific terms. Now, the unit of work, work done and energy both are similar because it's only the ability to do work. So both of the units are same only. SI unit of work also was Joule and energy also it's Joule only. Similarly, CGS unit is Erg. There are different forms of energy. We are we are seeing in day-to-day life different forms of work done in our day-to-day life. Here the different forms of energy are mentioned over here. First one, mechanical, heat, sound, electrical, nuclear, light, chemical, magnetic. We'll see in more detail. First one is potential energy. Now, what is potential energy? It's the energy of body due to its position or change in shape. So, due to that change in position or change in shape, it possesses a certain amount of energy. So that's why it comes in the category of potential energy. We see it example of water, which is stored at a certain height, right? So now, when water is released due to gravitational force, it will flow in the downward side. So that's why that energy is flowing from upwards to downwards, and that energy which is possessing due to the height of this is called as potential energy. Similarly, spring also contains energy. It's also it comes under the category of potential energy. When we release the spring, it will bounce back. So it's also one form of potential energy. Similarly, here also, when we release the this object, it will throw its energy and release this to the target. Similarly, the formula of potential energy is energy and work done. Both we can mention over as the same force and displacement. So, in when we call in terms of potential energy, force is mentioned by m into g. While in case of work, force is defined as m into a, but here it will define as m into g and displacement. So the potential energy formula is given by W is equals to mgh. G is a gravitational constant 9.8, while h is a displacement from certain height, the distance from certain height towards the earth. Now here the some more nomenclature of potential energy is given. Potential energy mgh. Now when it's a positive potential energy, so it's called as positive mgh. When potential energy lost by the body, it's called negative mgh, and total potential energy which will be zero. So total gravitational force is a conservative force, we can say that. Similarly, the another form of energy is kinetic energy. When any particular body is in motion, it produces kinetic energy, and due to that, it its formula we can derive it in the subsequent slide. But first of all, let's have an example. A moving cricket ball possesses kinetic energy. So when I throw a ball from one person to another person, so I have done the work to throw the ball, and the other person has done a work to catch the ball. So in both of the things, energy is released from person A to person B, and that kind of energy comes in the category of kinetic energy. Similarly, every moving part in the engine possesses kinetic energy. So here likewise you can say. Similarly, the formula of work done was force into displacement. So W is equals to F into S. But here in terms of kinetic energy, we take into account acceleration, ma, which was gravitational constant in terms of potential energy. So here ma into S. Now A into S we know by the formula, it's given by this. So by simplification of all of this, we can get kinetic energy is equals to half m v square minus u square. Now in general, when u is equals to 0, so we can tell kinetic energy is equals to half mv square. So which is directly proportional to the mass of body and directly proportional to the square of the velocity of body. So when mass is double, kinetic energy is doubled, and mass is halved. K is also halved. So likewise, now we have gone through the different formulas of work and energy. Now let's have an overview of power. Now what is power? Power is defined as the rate of doing work or consuming energy. So its formula is P is equals to W, or work done or energy divided by time taken. So P is equals to W by T, or we can say it as E by T. Now, similar to work and energy, power is also a scalar quantity. Its unit is watt. So watt is equals to joule per second. The unit of work or energy is joule, and unit of time is seconds. So by combining both of them, the unit of power is joule over second, or watt. Similarly, these are the different conversions given over here. There are different units of watt, megawatt, kilowatt, horsepower. 1 horsepower, which is equals to 746 volt. And in terms of commercial unit also, we can count kilowatt hour. So there are different units of power and energy. The commercial unit of energy is equals to kilowatt hour. Okay. Now here different transformations of energies are given over here. You can have a look over here, and at the end we will study law of conservation of energy, which states that energy can neither be created nor destroyed. So energy changes from one form into another, the total amounts of energy remains constant. So when body throw upwards or drop from height, the total mechanical energy at each and every point on its path remains constant. So similarly, there are examples given over here.